Good afternoon, and welcome to the 11th session of the fall 2017 semester of Sunoikisis Digital Cultural Heritage. Today we have the second session from a block of 4 sessions focusing on 3D. Today's session is about 3D modeling and design, and it will be presented by Graham Earl from King's College, Tom Flynn from SketchFab, and Valeria Vitale from the University of London. Please.
Oh, thank you, Rada. Can you hear me?
Yes.
Great. I will start with a brief introduction of 3D modeling and, in particular, computer-aided design, and quick overview of the main ways that it can be used for cultural heritage and, in general, the study of the past. So I will start screen sharing. Yes. Okay. Full screen. Okay, there we are. So let's start with a simple definition of 3D modeling that is, more than being a very neat and univocal definition, is just more something to help us distinguishing it from other technologies, like, for example, the 3D imaging that we have discussed last time. So we could say that 3D imaging is more about creating digital replicas, digital images of existing objects, while 3D modeling, it's more about creating a digital 3D representation of something that is either concrete or abstract, and of an existing or non-existing object from scratch. So the most common technology for 3D modeling is computer-aided design, which are, you're probably familiar with that. Those are the softwares that architects use, or if you go to IKEA, you will have a nice model of the room that you want to furnish reproduced in computer-aided design. There are, of course, other options. There is procedural modeling that Graham will discuss a little bit more in detail just after this introduction. But we also have other options, like, for example, we could use virtual worlds platforms like Second Life to build digital representations of buildings or other objects of interest. We have game engines that can allow us to both make interactive the models that we created in a CAD software, or build some of the elements from scratch as well. We have digital sculpting that kind of simulate the act of shaping the raw matter more than creating geometric shapes. And the last is just three dots, because it is it's a changing panorama. New technologies always come up, and they can all be useful in particular context. But as we said last time, one of the most important thing is, okay, why should we use 3D modeling to study, to investigate cultural heritage? Well, there are many answers to that, and of course, each researcher have their own purposes, their own reasons. These are just some of the applications of 3D modeling that I came across, in the past years, just in my own experience. So let's say that for me, the most straightforward application is the possibility to visualize something that do not exist anymore, or maybe that never did. We could digitally develop architectural or anyway material projects and designs that were remained at the status of project, and were never became actual. But we can also use them as, let's say, simulating spaces. They allow us to test hypotheses that it would be impossible or very, very difficult to test in the material world. So, for example, we could test on the reproduction of a building the effect of lights and shadow. We could test water features, as we can see in this model of a Pompeian house. We could investigate lines of sight, for example, what was visible in a built environment from one point, and what remained hidden, what were, for example, the pieces of decoration that were more prominent, and things like that. We could even simulate planets alignment, as it has been done, and on the, I think this is the Hadrian Villa in Tivoli. We could use algorithms to simulate structural strength. We could even use 3D modeling just to, for communication purposes, to make architectural plan of ancient building more understandable to non-experts, and so on. And in general, approaching cultural heritage from a digital perspective and creating 3D models or 3D replicas of existing artifacts has quite a few pros, and I just want to pinpoint the most apparent of them. So in the first place, for example, developing a digital restoration, virtual restoration of a piece of cultural heritage is way cheaper and often more manageable than starting a material restoration of cultural heritage. That, of course, is also important, but it's not always possible. And although restoration is definitely important and welcome, it is also problematic. And there are many examples when let's say material restoration of cultural heritage has proven to be too invasive and almost to cover the identity of the ancient heritage. And one very famous example is the Palace of Knossos that was restored at the beginning of the 20th century. And according to various art historians, it bears quite clearly the influence of the artistic scene of the beginning of the 20th century, maybe more, or definitely, more than we like, compared to the authentic Minoan decoration. It is also, potential infinite, which means that we're not stuck with one single hypothesis. We don't have to restore a piece of cultural heritage only once. We can develop variants, we can follow different theories, we can experiment with different colors, and we can, of course, then justify our and back up our various hypotheses, but we don't have to necessarily choose one, excluding all the other possibilities that might be, as much likely as the one that has been developed. And it's also potentially open-ended, which is an incredible plus for basically all digital products, which means that if more or better information, or if more and better technologies come up later, we can implement, we can modify, we can add on top of our digital work. And another thing that I want to mention quickly is that 3D modeling is a very interesting technology per se, but I think that the best approach to all the various 3D techniques, which is also why we have decided to have this, kind of block on 3D, is the way they interact and how they can be used together and how they can enhance each other. So, for example, 3D modeling could be very successfully used in combination with laser scanning, let's say. So, as we can see in this example, that was this is a 3D model of the Trajan Villa developed by Nouriel, and there is a laser scanning of the actual ruins, and then a CAD 3D model of the hypothetical restoration of the place. And we could interact with the outcome of photogrammetry, as we will actually do during our exercise. So, for example, we could have a CAD model of the built environment and photogrammetry of the portable artifacts of the smaller objects. We could interact with motion capture, for example, as in the projects that restored ancient Greek and Roman theater, and then they used motion capture to simulate the presence of the actors in the ancient space. We could couple 3D modeling with multispectral imaging or RTI, using this imaging to texture the 3D model and possibly even switch from one texture to the other, revealing, the various approaches to the same object. We could introduce 3D model in augmented reality and so on. And really, it is a very, very lively panorama, and different interactions are still to be explored, but this was just yes, my brief introduction to 3D modeling, and now I leave the floor to Graham to talk more about procedural modeling, I think.
Okay, thank you very much. I'll just start the screen sharing. So someone tell me, please, that it's working. Can you see the presentation now?
Yes, we do.
Okay, marvelous. Thank you. Yeah, thank you, Valeria. So I'll touch on a couple of the points that you raised there and introduce some examples. In particular, I'm going to sort of expand on the idea of procedural modeling. So I think the key thing is that most of the computer-aided design, or perhaps all of computer-aided design and modeling tools where you're creating objects from scratch, use some element of procedural, or sometimes called parametric, modeling. So last week, as part of the scanning and imaging, I talked about the different kinds of primitive objects, but particularly things like points and lines and faces. And normally, one doesn't assemble 3D objects in modeling packages from scratch using those. But more often, what one uses are sort of primitive objects, but then modified according to parameters. So those parameters might be, as I've got there, you might be creating a box, and the parameters are the size of the box and the number of facets, triangular faces that make up each side. Actually, kind of professional modelers use a combination of this kind of parametric approach and a very fine-grained direct modeling approach to get the best results. But the parameters that are driving the creation of these objects can be extremely complex. So the example of a procedural modeling tool I've got there, City Engine, can use GIS layers, so Geographic Information Systems layers, to define the creation of city blocks entirely automatically. And those city blocks function as if they were made up of individual architectural components. The way in which that works is via a kind of a related approach, which is shape grammars, which you'll see there as number 6. Shape grammars in architecture are ways of abstractly defining the relationship between walls and windows and doors, such that projects like Rome Reborn, where there's a link to the project there, can generate thousands of buildings entirely automatically or largely automatically. You write a script, you provide the shape grammar, and you tell the software to generate parametrically, procedurally models for you. If you also follow that link, you'll see another implementation of this using the procedural modeling approach. The last point on there is that this kind of procedural modeling relates very closely, and in fact has software in common with what's commonly called generative architecture. Tools like Grasshopper, which are contributing to the kind of the efflorescence of very organic modeling that we see in architecture. Just a related term is predictive modeling. So if you think of procedural modeling as creating three-dimensional objects on the basis of scripts and rules and data, predictive modeling is doing the same thing, but the data that's being brought in is about the real world, not about the real world in terms of how buildings are made up of their individual components, but things about the real world in terms of how it functions. So perhaps in this case, how light bounces across the surface of an object at Çatalhöyük in Turkey. So in predictive modeling, you're using data about the world, the real world, in the computer so that it can procedurally represent those same properties. And the argument is that if you do that, then when you create a three-dimensional object or space using real world data, your perception of those objects in the virtual world has more in common with your perception of the object in the real world. That's a moot point, but it's something that you might want to look further at. I've also introduced this because, as Valeria said, many of the data that I talked about last week, including RTI, allows you to produce these kinds of predictive modeling outputs. Here's just a very quick case study of the procedural modeling, building on what I discussed with respect to Portus last week. So these are some conventional archaeological data. You've got a plan, you've got a photograph, you've got some geophysical data relating to a particular building. This is work by James Miles, where volumetric, quite simple models were produced on the basis of that information, manually, not automatically, and then tested according to the structural properties of the potential building. So using the material information, the material that it was made from, the spans, and so on, to identify whether or not essentially the building would fall down or not. Having done this kind of analysis, we can, and here's another example of hypothetical roofs, we can pull that in along with other sources of information. So it might be, here we've got measurements relating to the building. This is work by Matthew Harrison from Southampton again. So we bring in the structural data, we bring in these measurements, we bring in ranges of information, so a range of potential heights for the piers. And we can even bring in logical things, so if statements, like if it's barrel vaulted, then it's more likely that it's pitched than it's a flat roof. By bringing all of this information together and loading it into something like City Engine, which is what Matthew did here, the computer is able to generate dozens, indeed many hundreds of permutations entirely automatically, both of the exterior and the interior of the buildings. And this isn't to use the computer to replace the skill of the architectural historian or archaeologist, but instead it's to use the computer to reflect back to us the scope of the interpretations of the data that we are saying is underpinning our interpretation. So it's a visualization approach. It's not a way of replacing the knowledge of the expert. So that's a quick run through of the technology, and I hope that that's given you some pointers for further study. Thanks. Oh, sorry, I should say, this is one of the final potential outcomes, bringing that together. So the procedural model, then overlaid and reworked with old data, case by Grant Cox, to produce a more, I suppose, perceptually pleasing and more realistic representation of this same building at Portus. Thanks a lot. Okay. Who's next? Is it over to Tom?
No, it's me again. Thank you.
Ah, okay.
Yeah.
Thanks.
Yeah, I wasn't sure I could unmute myself. Yes, I can.
Okay.
Okay. Okay. So, what I want to discuss with you now, it's going back to why we should use a spatial approach. Why should we use not necessarily 3D modeling, but how putting things in a spatial context can help us understanding cultural heritage? And I'm just gonna go through a few major points about that. So, for example, I think that where something where something used to be, when we look at an ancient artifact, does affect our understanding of it. So, for example, if we look at this inscription that was found in Pompeii, that says the Calidus, the Thracian gladiator, is the delight of all the girls. So if we look at this inscription, and we know that this inscription was found, for example, I don't know, in a bar or, you know, on the street, maybe, you know, the kind of character that we picture is, you know, someone pretty cool. It's a very successful gladiator that is actually the delight of all the girls. But if we know that exactly the same inscription, so exactly the same, we can call artifact or object, was actually found small and gloomy and dark cell of the gladiator, of one of the gladiators that probably wrote it by, you know, about himself, then our perception of that character, then the idea, the story around that artifact becomes suddenly completely different, just because we have changed the location. So another, you know, major spatial concept that can really affect our understanding of cultural heritage is scale. If this is a virtual restoration of the Theatre of Pompey in Rome that was done by K. Viola at King's College London some years ago. And I'm not sure you can see it, but there is a tiny black dot on the stage. I'm gonna, zoom in for you. That tiny black dot that you can barely see, that is a person. And I don't think I never had a clear idea of how huge the Theatre of Pompey was until I saw this virtual reconstruction, and until I saw, you know, how tiny looked a human person there. And of course that made you wonder, you know, about what was going on there, because when you realize that the scale is so different, then maybe you start asking different questions, and you start asking what kind of performances, for example, could take place in such a, you know, a huge place where also, you know, visibility is completely different from a traditional theater. And, you know, of course, I don't have any answer for that, any hypothesis, but I was just struck by how I started looking differently at the building after I realized, you know, its actual scale. And another could be the point of view. So sometimes bringing our knowledge of a place into a three-dimensional spatial context can also give us some insights. For example, there are a number of houses in Pompeii that have a garden, okay, a small garden, but don't really have an entire colonnade around the entire garden. So this is one example. This is the house of the large fountain, and it is, you know, quite straightforward to understand that where you see the letter A, that would be the entrance. So the that's where the, you know, the street would be. So it's quite straightforward to understand that they put there just 3 pillars that could be easily, you know, could be easily seen passing by through the entrance, to simulate that they had an entire colonnade, for example. And I think it's even, you know, even more amusing in this other example, that is the house of the small fountain, where there isn't even, you know, any the pillars, the columns are not even evenly spaced. They are just arranged in a way that a passerby can assume, you know, thanks to the perspective, that the owner of this house has a wonderful, complete colonnade around its garden. But another really, really powerful application of 3D modeling and in general of spatial representation of cultural heritage is that it helps us putting things in context, and it helps us highlighting the relationship between things. So for example, if we look at this statue, at these beautiful artifacts from Herculaneum, there are, of course, already a number of things that we can understand and that we can say about this artifact. It's already a rich, interesting object. But when we know that this artifact was not, conceived in isolation, but it was part of a group of dancers, then, the way that we look at this artifact changes. Definitely, and we start seeing, a pattern and the interaction between them. And when we find out that these group of statues, they come from a villa, the Villa of the Papyri. This is not the Villa of the Papyri. I'm really sorry. The only thing that I could get, free of copyright was this picture of, and it's part of the Villa of the Papyri building in the Getty Museum. But let's pretend it's the Villa of the Papyri. So when we find out that those statues were arranged around a pool in a villa, then again, the interaction about the built environment and the statues and the water, they all add to the meaning, to the artistic meaning, to the cultural meaning, to the social meaning of that object. And it becomes immensely more informative. And if we just think, for example, how fond were Romans of the interactions of the various elements, for example, in their architecture, and for example, the interaction between the built environment and the natural environment, and the real gardens and the portrait gardens on the decoration, and the real statues and the portrait statues, and so on. When we put this information together, thanks to 3D digital technologies, we definitely make the sum of this element way more informative than the things when considered alone. And also thanks to 3D modeling, when used, for example, in combination with GIS or landscape modeling, we can also investigate the interaction between built environment, human-made environment, and the landscape, like in this wonderful example of the temple of Jupiter Answer in Terracina, or the interaction between various buildings in the cityscape if we widen our scope a little bit. For example, from what part of the city some buildings were visible on, or what was the interaction between different buildings in the cityscape. And again, so this was just a brief overview of why using 3D modeling and other 3D technologies can help us approaching cultural heritage. And now I am going to introduce something about documentation of 3D modeling, which is quite a difficult topic because because everyone loves a beautiful 3D model, and everyone likes to look at beautiful images. But if we don't know how these images have been developed and according to which criteria, then it is impossible for us as members of the public or as scholars to assess a 3D model and say how reliable it is. Which is why the London Charter, which is a guideline for the use of 3D technologies for cultural heritage, highly recommend that along with each 3D model documentation about it and the way it has been developed and the sources that have been consulted, they are always disseminated together. However, although everyone agrees on that, this doesn't always happen. There isn't enough documentation of 3D models for a number of reasons. I mean, it takes a lot of time. It's hard to convince people to pay for it. there is no clear standard on how to do it, and so on. And of course, there are some examples, and they're great, and they are very informative, and they are sometimes embedded into the visual output, as we can see in this example from the KVL, where the restoration of a fresco is color coded like a street light thing. So the most likely thing are green. The slightly more speculative are yellow, and those that are entirely speculative are marked in red. Or we could produce let's say appendices, other digital products that go with our model. We could develop a dedicated website. We could publish our model and a printed traditional documentation of it. There are various strategies, and the fact that there isn't a standard shouldn't discourage us from trying. And during our exercise, I will definitely ask you to think about what you're doing and why you're doing it, and try and document it. And later on, Tom will show us that maybe using the annotations in SketchFab might be a way to start recording and documenting some of the information. And this is, me going on and on of how difficult documentation is, but we're running out of time, so I just want to say that it is really crucial to produce documentation for a number of reasons, for transparency, but also for, let's say, to declare our bias, to show the process that brought us to developing a particular 3D model. And when we produce a 3D model of something, we enter, a very long and glorious tradition of reproducing ancient works of art. And I'm just going to show you a few examples from the Temple of Isis in Pompeii. And we are extremely grateful that some people before us produced some visual documentation, because some information after centuries only survived through these reproductions, through maybe one day through our 3D models. They will be the only trace that we have about some ancient artifacts. So, for example, the mosaics depicted by I think it's La Vega here, they only survived. The information about it only survived in the documentation. But reproductions are also, human-made, so they are, they are biased, and they might have different, different purposes. So, for example, in this reproduction of the Temple of Isis by Piranesi, there are, two huge walls missing, just because it was more artistically pleasing. It was clearer to remove. It was easier to remove those walls to show better the temple. Or in this other representation of the Temple of Isis in Pompeii, there is damage that has been introduced here on this wall that was never there. It's just, again, another trick to show in this perspective more of the temple. Or we have these hypothetical restorations that are, believe me, there is no way so many people could even enter the Temple of Isis, and definitely there is no way that a bull could be in that tiny space between the altar and the temple. So 3D representations all representations are incredibly useful, but are always biased, and that is why it's absolutely crucial to produce documentation. And I am going to start now our tutorial, where we will build a little bit one of the room in the Iceum, that is the space that we have just discussed together. I won't go through the entire exercise, but you will find the handout, so you will be able to complete it yourself. And after, we will pretend that we have completed it, and then we'll see what we can do with the model after we have produced it. So let's open SketchFab, which is the software that we're using for our to build our 3D model of the ecohistorian in the Iseum in Pompeii. This is the SketchFab interface. The first thing that we can do is to select the human character that you usually find in the scene, and just get rid of it. I recommend that you use a 3-button mouse. It just makes things a little bit easier. But of course, I mean, you can do it on your laptop. No problems. Before we start, I'm just gonna show you a couple of very basic things about how SketchFab works. So, for example, let's create a rectangle. So if I go over the rectangle and click on it, you see that this gray area has now a lot of blue dots. It means that it's selected. So if I want to delete my rectangle, and if I do this, if I select and click delete, that's what happens. We have deleted the surface, but not the lines, because in SketchFab there is a separation between the surfaces and the lines, and they have to be. If we wanted to delete, everything, we have to select everything. So everything has to be. Everything has to be blue. So. Great. We can do that. Okay, now that we have select everything, we can delete everything. And again, before we start, another thing that I wanted to show you, if we select one line and we delete it, that's what happens. We also deleted the surface. That's because there cannot be a surface if the perimeter is open. So this was just a quick introduction to the logic of SketchFab. And let's also save this file before it just crashes during our class. Okay. Now we're ready to start. We are going to build the ecosysterium now, following the actual measurement of the space that have been taken in Pompeii. And you'll find the measurements on the handout. So let's get started. So let's select the rectangle tool, as we've seen, and draw a random rectangle. Now, let's type the actual dimensions that we want our rectangle to have. So 13.2, and then comma, and 7.5. So these things, okay, that was not comma. So they change from computer to computer and from operative system to operative system. So okay. Nope. Okay, try with commas, try with semicolon, try with. Okay, that's not the thing. Yeah, sorry, I'm on a Mac. I usually do this on a PC. Nope. Okay. Okay. So it should be. Yeah, that's it. So if you are on an Italian Mac, you separate with the with the comma, and then you separate the 2 dimensions with the semicolon. All right. As you've seen, to input precise measurements to our shape, you just start typing, and you will see the numbers appearing in this field here. So this will allow us actually to have quite a good control on our modeling process. So okay, let's go to the next step, and let's select this tool that is called the offset tool, and let's create our walls. So what are we doing here? It's creating a smaller rectangle inside the one that we just did. And again, we can just create a random one and then input the right dimension that we want it to have. And we want this offset to be 0,44. So you just see it adjusted automatically. You type the right dimensions, and then it works. What we want to do now is to raise this surface that is going to be the surface of our walls, and to pull it up. So what we do is we select the Pushpull tool, that is this one, and then we select only the external part of the rectangle. You see that it's now dotted, and we click and drag it up. And again, we can just release it at any point, but then we enter the number that we want, which is 6. We want it to be 6 meters high, and then we click enter. So we have our room starting to shaping up, but now we want to build the entrances to this room, and to do that, we have to use some guides. And the best way to use some guides is to have a very clear view, so that we don't get confused. So we go on camera and standard views, and we select front. And this is quite neat and clean view. So we are now ready to use to create our guides. So let's go on this tool here that looks like a tape measure. And we go on the edge of this rectangle, and we click and drag. And again, we can release it randomly, but then we're going to type the right dimension that we want, which is going to be, and you'll find all these numbers on the handout, 0.73. Okay, and then I'm just following quickly. Okay, and then we do exactly the same on the other sides with the same numbers that, again, you will find on the handout, 0.73, 5, 308, 7, and 5. Okay, and now we do this from the bottom, and it's 3 and 3, 6. Okay, now we have a layout for building our 5 arches. So let's start building these rectangles here. Okay, which could be our doors. They are, good enough, but we want, arched doors. So we now select the arch tool from here. Is this one, the 2-point arc, and we are going to create an arc using our guidelines. So we click on the first point, we click on the second point, we follow this line until the midpoint. You see that SketchUp is telling us you reach the midpoint, and then you bring it up until you touch the guideline, and then you click, and you have created your arch. Let's do it again. First point, second point, and then when you reach the midpoint, you take it up, and then you click, and you have created your arch. Last time, midpoint, up. Okay, we almost have our arches. We don't want these lines because they don't make any sense. So let's just select them, and and just delete them, actually. It's easier with the eraser. Good. So we have now 3 of our 5 arched doors. And we only have 3 because I want to show you how to copy something. So let's select the lines that we want. So to make a group selection, if you are on a PC, you use you hold Control. If you are on a Mac, you hold Shift, and you should see, this plus minus sign appearing. So, okay, we have selected, the part. We have selected the arch door that we want to copy, and then we use the Move tool, which is this one, this with the 4 arrows, and still holding the key that you've used before, either Control or Shift. You just move. Oops. Is this? No. Okay. You have to hold Alt and then move it, and you are also duplicating it. And that's it. So we have now 5 arched doors, and we can get rid of our guides. Okay, so it looks a little bit cleaner now. So these doors are great, but are a little bit useless because we cannot enter. So what we do is we select the pull tool again, and we push them until we open them. And after we do the first one, we just double-click on the others, and SketchUp will reapply the last operation that we did. And that's it. And I'm gonna do just one last thing, and then I think I'll hand it over to Tom. I'll show you how we can apply a texture on one of the walls, and then we will pretend that we've done all the walls and the roof as well, and we'll move to SketchFab. Okay, let's say that we want to put an image on this wall, and we will use an image that is actually an historical document. It's the record that some artists during the early excavations made of that wall before it was stripped and moved to the Archaeological Museum of Naples. The area that we have covered by that fresco is actually smaller than this hypothetical height that we just assigned. So let's create another offset on the wall that reduces it a little bit, and let's say that is. Okay, and this is just a random value that we have assigned, but it's to bear in mind that, for example, when the frescoes were taken out from the walls, they were not usually, the people that materially detached them from the wall didn't, needed a little bit of room for maneuver. So there was always, a little bit of the fresco that got lost. And this is really just a random number. It's more to show you the various tools in SketchUp. So let's upload an image, and from File menu we go into Import. Okay, and the thing that we want to import are all the image format, all the possible image format. Okay. So all supported images, image types, and let's go find our image. That is okay. Let's give it a moment. We should see the image appearing. Okay, let's try it. I think this is just my computer being very, very slow. I will re-import the image. Okay. Okay, it's behaving better now. So we have this image that's just following our pointer. So we go into the first corner where we want to position it, and we click, and then we see that the image expands. And when we reach, the other edge where we want to position it, we just click again, and we have kind of released the image. So normally I would just do that, but Tom was telling me that it's better if you want to then upload your model on SketchFab to actually move the image a little bit away from that surface. And you will find this in the handout as well. So I hope I'm getting this correctly. Is that the right axis? No, it's not. No, we don't want to rotate it. Okay, let's say that we have moved it of, I would say, 2 centimeters. And that will make up for the error in SketchFab. So now, okay, let's pretend that we have textured everything and that we have imported one of the objects that we produced with the photogrammetry last week. That we have, positioned it in our 3D landscape, and let's see what else we can do after we have finished our model. That's for you, Tom.
Thank you, Valeria. Okay, well, just going to minimize this. So I work at a company called SketchFab, which is basically an online viewer for 3D, the same way that YouTube is an online viewer for video. The idea being that you can upload a file, a 3D file, and then use the tools in SketchFab to share your work in its native form, as opposed to either videos or screenshots. So what I'm showing you here is just the presentation that is on the GitHub page. I'll just skip forward a bit, and there are step-by-step notes on what I'm going to show you now to take you through all of the steps. So here I am in SketchUp, and this is a model that Valeria kindly supplied to me. And as she said, I've just moved these images slightly away from the walls. And the reason that I've done that is that in 3D space, if two surfaces occupy the same position, often 3D software and viewers like SketchFab can't decide which surface to show to the viewer through the screen. So there's something called Z or Z fighting, where the two surfaces kind of pop in front of each other. But that's a story for another day. So here's the model, and all I'm going to do to begin is to export it, going to File, down to Export, and click 3D Model. And we want to make sure that the file type is a collada file, a .dae. We'll give it a name. I'm just going to navigate to a folder that I want to save it in. And then we also want to check the options for the export. And so this little pop-up comes up. And we want to make sure that export two-sided faces is selected, triangulate all faces, export hidden geometry. It's not so important here, but if you're doing some more advanced modeling in SketchUp, you might want to hide and show geometry. And finally, a very important one is to export the texture maps. So that's the images that Valeria was just showing you how to import, and also the texture for the roof that you'll be adding when you follow the handouts. So with those 4 checkboxes checked, click OK and export, and just wait a couple of moments while the software packages everything up. The native file format in SketchUp is something called an SKP, so that needs to be converted to this other format. So I have my folder already opened here, and this is what you should see when you export. You have a DAE file, the collada file, and then a folder with the images that you've imported and the textures that you've imported. And what we want to do is select them both and send them to a zip folder. So you can do this any way that you want. On Windows, right-clicking and going to send to, I'll just send it to the desktop as well. Send to compressed folder, but it's similar on a Mac as well. So we have a zip file. I can now close SketchUp, and I'm just going to quickly show you around SketchFab. So this is the SketchFab interface. This is me looking. This is my user profile on SketchFab. So these are all 3D models that I have uploaded. As a quick aside, there's about 600 museums and cultural organizations sharing 3D content on SketchFab. So there's a British Museum, the Discovery Programme from Ireland, RMN Grand Palais from France, Museum of Santa Cruz Art, lots and lots of different people sharing 3D content, in part because there is somewhere to share it in 3D. So SketchFab provides the opportunity to show people your 3D anywhere online, but also in part because museums and organizations are producing more 3D through 3D scanning or through using simple tools like SketchUp. So with that aside, I'm going to jump back to my folder. So when I'm logged in, if you haven't got an account, you'll need to sign up to SketchFab for a free account, and we can upgrade that for you for free to the Pro tier as the offer to educational institutions, something to bear in mind. All I'm going to do is drag over my zip file and let go, and then this window will pop up, and this is simply where we give our model a name that will be displayed on the site and a description. I've got a pre-prepared text that I want to add as the description. And what I've done in here is I've added some links and also an image. There's a special format called Markdown that lets you add images and links and text formatting. So that's covered in the handout for this portion. So this is going to add a bit of text description, some links, and an image that I've just grabbed from Wikimedia. I'm also going to add the right category. This is important to help people find the content that we're uploading. SketchFab hosts all kinds of different content, from video games to visual effects to 3D artists, as well as museums and cultural heritage. Tags are also a good way to help people find your work. So I've actually got some pre-prepared here as well. So I'm just going to type digital classics and Sunoikisis DC. So that will help me find other models that have been uploaded through this program. Everything else as it is, and hit continue. When you upload a model, the same way that SketchUp has to process your 3D into one format, when you upload it to SketchFab, it will be processed into another format called GLTF, which is an efficient file format for displaying 3D online. And depending on the number of uploads at a given time, it might take a little while. This shouldn't take very long because it's not a very big file. The larger your 3D file as well, the longer it will take to process. Once it's done, we'll be taken to the model page. He said, hoping that this won't take very long. Any minute now. In the meantime, maybe I'll just keep an eye on that, but then come back to that. Just to go back to sort of some of the people that are sharing 3D, there are different ways that people are producing 3D I mentioned. For example, the University of Dundee has been using handheld scanners and CT scanners to produce some really amazing models of animal skeletons and specimens there. Most museums are using photogrammetry to produce 3D. Some museums are using software like Blender or 3ds Max to recreate all kinds of, whether it's an object or a scene. Okay, I'll just jump back to the other tab just to show you. This will be something like what you'll see when your model has finished processing. So there's the 3D area, and I can rotate just using left click and drag. I can zoom in and out by using my mouse wheel or two fingers up and down on a trackpad. And if I want to pan, I can hold shift or right click and drag to pan the scene. If, for example, if I end up with my model somewhere over there, so when I'm rotating it's kind of not in the right place, I can just double click anywhere on the background to recenter it. Just to briefly look at the description that I added. There's the text and links and the image that I've grabbed from Wikipedia as well, the Temple of Isis. I hope it's the right one. I must admit that my background is not in classical civilizations. Anyway, so this model isn't published yet. What we want to do is, while it's in draft mode, is to adjust the 3D settings. So there's a button over here. I'm going to click, and it will take us to the 3D settings. So we've got the 3D viewer again that I can click and drag. And then we have all of the settings, and there's a panel that goes down here, as well as tabs that we can move across. We'll do this one by one to get the scene looking how we want it to. So to begin with, I don't want to adjust anything in the general or camera panes, but I do want to adjust the background. So this is the kind of colors you can see here. And all I want to do is just reduce the brightness a bit so that the model stands out. You can also type values in here. So I'll just change that to 0.5. Notice that there's a kind of a pink cast on the model, and I'll show you now where that's coming from. So that's all we're going to be doing under the scene tab. We're going to move along to the lighting tab next. And in this tab, there are two main options, the lights, which we'll come to in a second, and the environment. Currently, it's using something called the Queen Mary chimney background to light the scene. What I'm going to do is, there are obviously various backgrounds, but the one that I've used in the example is called Tropical Ruins. And this is now lighting the model using the color information and the brightness information. What I'm also going to do is rotate the scene, or rather the background. So I'm going to hold the Alt key and rotate the lighting environment just so you can't see that. Zoom in a bit. Do it again. So you have to alt-click on the background for this to work, just to adjust the shadow so that it's kind of just hitting the front of the building and then casting the shadows from the pillars. This is simply just for the look of the thing. So we've adjusted the kind of background and the orientation of the background. We can also do it with this slider here. And also the light intensity. So if I turn it up a lot, you can see how it's bleaching out the top parts of the model up here. So I don't want it to be too bright. So somewhere around 1 is fine, maybe a little bit less. 0.3, I'm going to leave it there. And I'm going to close that. I'm going to add 1 lamp, so 1 simulated light to this scene. So I'm going to turn on the lights. I'm going to hide 2 of them by clicking the little eyeball symbols, and then select light number 1, which is currently set to a directional light. You can see it down here. I can grab any of these widgets to move it around in 3D space. You can see it's kind of over there. I'm going to change it to a point light, which instead of a directional light, which is coming from a certain direction, obviously a point light acts much more like a regular light bulb in that it has a sphere, a sphere of illumination. I'm going to center it in my scene by hovering over the first light here, and there's a little target that appears. I'm going to click that, and it moves the light to the center of the scene. And what I'm going to do is use the axes just to move it right into the center, just so that we're lighting kind of quite evenly. We can make adjustments to how bright the light is and the fall off. What I'll do is I'll leave that. Again, you can use the sliders or type in values. I'll, leave the intensity at 50, and also I'll leave the actually I'll leave the fall off at 40. Oh, wrong way, 60. Okay, so if I move around, you can see how the light plays mainly on the surface of the floor here. We can adjust how the materials in our scene react to the lamp as well in the next tab. So there's a materials tab with a little icon, looks like an image. And what I'm going to do is simply click on the material in the scene that I want to edit. And all I'm going to adjust here is the roughness of it. So if you see the effect this is happening, it's making the ground look very shiny in this instance. Or if I go the other way, looking at less shiny. So I'm going to type in 60 here for roughness. There are lots of other options, as you can see, but we're not going to be using them with this particular model. The next tab that we're going to adjust is the post-processing. Really what I'm showing you here is just how to make your 3D look nice, so that it can help you communicate whatever it is you're trying to communicate with the 3D. You can have very nice looking 3D, but if you haven't got some context to it, then it's a bit useless. So in the post-processing filters, I'm just going to switch on the first option, which is SSAO, which stands for Screen Space Ambient Occlusion. And I'll just show you kind of what that's doing by zooming in a bit. So what SSAO does is it simulates the trouble light has in getting into nooks and crannies. I'm going to just turn down the effect a little bit, turn up the radius a little bit, double click on the background just to get recentered, shift click to turn it around. So again, this is just adding to the visuals. I'm going to turn on depth of field, which simulates a camera lens so that things in the background and the foreground have become slightly blurred. I'm going to turn the foreground blur to 30, and the background I'm going to leave on 50. And now I can click on my model and it will focus on these different spots. So I'm clicking on the front of the building here. Okay. The last one I'm going to click and turn on is vignette. So that just adds a vignette to the scene. So now I'm happy with how it looks. I'm going to get onto the main sort of point of this tutorial, which is to add some annotations. I'm just going to jump back to the I'm not going to jump back to there. I'm going to jump back to my presentation because I pre-prepared some annotation text to use. And what I'll do is I'll just show you how to do maybe one or two annotations. One moment. My mouse, okay. So the first annotation I'm going to add is about the building layout. Minimize that. So, sorry, I'm still in the post-processing tab. What I'm going to do at this stage, I'm also going to just arrange my model and save the view with this button up here. And what that does is it saves this particular view as the thumbnail, but also as the view that a user will see when they load your model. So actually, I'm going to zoom in a bit more and then resave it again. So this will be the way people arrive at the scene. I'm going to click back to the scene tab for a second because what I'm going to do now is per annotation, we want to set the camera view and then add some text. So the first annotation I'm going to add is about the layout of the building. Thanks, Valeria, for giving me the text for this. So I'm just going to set a view, turn the camera slightly, and move back to my annotations tab. And I'm going to double click on my model, and up will pop this input field. So this is where I'm going to add a title, and then add this text into the description. Now I click OK, and it's added to this left panel. So now if I move my camera somewhere else, but if I click this hotspot, it will go back to the view that I set and also display the text. And this is slightly different in the preview, but it's essentially the same for a viewer. Once I've added an annotation, I get a preview of the camera location. I can change it and reset the camera so it updates. In fact, I want to keep it at the view that I had with this little camera icon. I can also delete the annotation and edit the text directly in this sidebar as well. I'll add one more annotation. So the text that I added there was the dimensions of the building are authentic and measured on site. And the next annotation that I'm going to add, again, I've just rotated my view. I'm going to a bit more, double click, and copy the text. This is all viewable in the presentation notes. You can copy and paste these or add your own copy and paste. And the second annotation is about the speculative nature of the roof elements. Click OK. So we could add more annotations. Maybe I'll just show you a bit more how it will work. Say I want to add an annotation to one of the image panels that were added. I have to get out of annotations mode because I'm going to double click. And if I double click in annotations mode, it will add an annotation. So I switch to the scene panel, double click on one of the walls and set my view first, and then I can double click and add an annotation. I'll just do this one last one and then I'm almost done. What I've got in this annotation, I don't know if you can see, is that the body text begins with 2 hash symbols. And what this does, if I paste it in and click OK, in this left panel, you can see that the text next to the 2 hashes is now a heading. And you can use different symbols to create different emphasis, whether it's a heading or bold or italics, and like I said before, add images. So that's 3 annotations, and I've already set the view, so it doesn't matter where I leave this model view right now. I'm going to save my settings in the top right, and I'm going to, well, first I'm going to exit, and then we're just going to publish it. Before I publish it, I'm going to quickly switch it to a private model, just so it doesn't get added to my feed. When you publish a model, anybody that follows you on SketchFab gets a notification. So I'm just going to set my model to private. Click the save button. Does not seem to be working. Oh well, people will have to see this. So, like I said, this view was set earlier, and if I click publish, just in a moment, we should get a notification of the link. So this is the link that I can then share. I can paste this into Facebook or Twitter, or I can use the embed code to share it on a website as well. It's the same that is up here as well. So there's our first view. I can click on the annotations to take the tour. I can use the arrow keys here to take a tour of what we've added. So that's the basic way to add context to your 3D model. There are other elements that you can use SketchFab to create virtual reality or augmented reality. I'm not going to go into that now. You can add audio to your scene as well, but we'll leave that for another time. Yeah, I'll stop there. I'm not too sure who's going to be up next there. Maybe back to Valeria.
Yeah, I think we're finished.
Okay, perfect.
Okay, thank you very much. Thank you, Valeria, Graham, Tom. It was a really interesting presentation. I'm sure we've all learned a lot of new things today. So now, please, questions, discussions.
So one question for Valeria, just quickly, is this workflow, SketchUp and SketchFab, SketchUp to build and SketchFab to publish, a workflow that you would use for your own models? And if not, what might you use instead, and why might you use something different?
Well, I think it is a workflow that could be used. It depends. I think how complex is the documentation that you want to attach. I think that for a straightforward basic documentation, I think that it works quite well, and it is definitely it is easy to share, and everyone can access it. So it has quite a lot of pros in, it's easy, it's uncomplicated. And you can, you can make references to external links and other stuff. Maybe if you want to reach a level of granularity for the documentation that is a little bit more in depth, then I'm not sure that would be enough. But I think it looks, it looks promising, and certainly for the purpose of an essay, or for example in the museum context, if a museum wanted to add, for example, not just the model, but also the metadata about the model and some information, about provenance or whatever, it looks like a good way to do it. So I'm sure that Tom can add more interesting things about SketchFab. But
I mean, I think that covered a lot of what I would have said as well. It's important to remember that SketchFab is a tool for sharing 3D. It's more for engagement. It wasn't built as an academic tool. So in the work that I've been doing over the last year with SketchFab, I've had lots of requests for all kinds of different tools to be added to SketchFab. For example, scale bars that are dynamic as you move in and out, support for volumetric data, say from a CT scan, different ways that it could be used as a teaching tool. For example, even as something as simple as multiple users being able to annotate the same model as a way for students or for even other academics to reuse data. These are all things that I'm listening to and trying to kind of push into SketchFab, but the roadmap that is currently underway, it's important to remember that SketchFab is a commercial company that has clients ranging, like I said, from 3D artists to architectural businesses to furniture makers. So it's got to kind of cover all of these use cases. But over time, we are adding new features. There's actually something called SketchFab, well, it's labs.sketchfab.com, which has a few features, experimental features like measurements. For example, you can click on 2 points on a given model to measure the distance. So it's getting better, but even with the tools that are already there, I hope people can use it for interesting uses.
Cool. And so you say SketchFab's primarily a communication tool. It's a viewer for these sorts of models. So the annotations you create are part of a view that you're creating to be viewed on the site. Can you also re-export a model with the annotations as well from that, or are the annotations, once they're in there, that's all that's the end of the line for the annotations?
Unfortunately, yeah, that's exactly the case. I mean, they are saved as some external data. So in theory, you could reach that data and reuse it. That's one. There's the IIIF standard for images. There's a 3D group looking into how do you get, for example, different 3D viewers, SketchFab and other 3D viewers, because there are more out there, to work in a harmonious way. And I think that's one thing. How do you define this point on a 3D object, even the camera angle looking at it, that can be reused, which would be amazing, I think, if it can be figured out. But got a feeling it might be quite a lot of work.
Thanks.
Okay. Does anybody else have any questions, comment? Please.
I had a quick one again for Tom. Can you instantiate multiple copies of one model in another one, or bring multiple ones together in the same place? And could you do that in order to stitch together kind of a tour of multiple objects or places?
Well, there's ways that I can answer this that are kind of easy to do and not easy to do. The simplest would be to create your scene, your 3D model externally, so using SketchUp or some other program. So create your environment where you have different objects that you've imported. So say multiple .obj files, multiple collada files, and then upload the resulting 3D to SketchFab. There is the SketchFab API can be used to create something called a configurator, or that's the term we use. So for example, it's been used by a few commercial companies to display a 3D model. The one that comes to mind is of a yacht company, and they let you in the viewer turn off different materials and parts of a boat, so the engine or the roof canopy, to display different meshes that are either hidden or shown. So they're in the original 3D file, but you're displaying or not displaying them. It's also possible to use that's the viewer API. You can use the data API to, if you hooked it up, for example, to a copy of Blender 3D running on a server and had an interface where you were going to try and create maybe a museum and you wanted to select XYZ artifacts and place them in your museum, you could have Blender running on a server and then export that to SketchFab via an API as well. So that's a bit of a sort of roundabout way, but it's possible, but it's not easy to do right now.
Okay, but I mean, amazing possibilities. I mean, like you said, in terms of teaching, I mean, it would be fabulous to be able to stitch those different kind of curated journeys around the objects together. Be really fabulous.
Definitely. The Réunion Musée National in Paris are interested in helping young students become kind of curators of their museums, and the University of South Florida Herpetology Lab, they were interested in the idea of having students annotate the same skeleton of a frog to learn the anatomy. So that, you can obviously see that it could be applied in various ways.
Thank you. Thanks a lot.
Thank you. So, does anybody else want to say something? I'm going to check to see on YouTube if we have any comments, but we don't. Okay. Well, if this is it, thank you very much once again to the speakers for this very interesting presentation. And good evening, or have a nice day, depends on the hour you're watching this on. Goodbye.
Yeah, thank you all. That was great. Thanks.
Thank you. Bye.
Thanks. Bye-bye.